Hey guys, we're going to talk about Pbr shaders and rendering today. I want to break down what it takes to make some of the game industry textures that you see in kind of all over these days and what's kind of trending in the industry. And that's because we're interested in realism, and that's kind of what I'm here to break down, is what is being used to create what we're calling realism in entertainment today. And so I have a bunch of shaders here. We will go over some of these and how to make them and what all these colors mean. I kind of want to start off giving you an example of a texture. And so you may be kind of familiar with the texture process. We're jumping more in depth on how to create and break down some of this information. And so this is kind of what we're getting at. I'm just kind of moving around so you guys can see some of how the light reacts to it, how we have different materials in here. If I zoom in, even got the circuitry in the back that seems to kind of reflect light as we roll around. And we got this LCD screen. Clearly this thing's been around a while, right? It has dust in between all the crevices. And so what does it take to make something like this? Well, we have our Albedo texture. This is basically all lighting information removed, just flat raw materials. And so there's no lighting information in here. You're seeing dust, you're seeing wear and tear, scratches, there's no lighting information. And then we use the Metalness Map, it's this next one here, to define what is metal and what is not. There actually shouldn't be any, oh that's dust, I was thinking that was AO. And then the Roughness Map. The Roughness Map will decide, as it says, how rough a surface is. And so these are the three maps. When you combine these into a shader, these textures, these three texture maps, when you combine them into a shader, they'll give you something like this. And why the industry seems to be obsessed with this these days is because it is really meant for artists. Pbr is not anything new. Pbr has been around for a long time. Renderers have been using it to get realistic results and realistic materials for some time, but the process has been kind of complicated in the past. And so this new buzzword that you're hearing, this acronym that's going around, PBR, physically based rendering, it's even kind of a funny name in itself because it's physically based, right? We're talking about how to achieve realism, and they're saying it's based in the physical world. And so even the name itself should kind of hint at the fact that this isn't, while there is math behind some of this, it doesn't necessarily mean that because you're using a Pbr shader that you're achieving realism. And there are some things that you need to know about the Pbr workflow to help achieve realism in this rendering model, Pbr. That'll help you achieve some realistic results. And so we're just going to step backward out of what it takes to create something like this. That's why I wanted to start with the final result and kind of show you where we're coming from when we create something like this. And so, like I said, these are the maps, but this is only the beginning. You know, how do you know what colors to use, right? And so let's take a look. When I'm going to texture something like this, I need to know what kind of materials I'm going to use. So I'm collecting reference. I'm looking online for, you know, what these things are made out of if I'm not sure. What kind of metal is this? What kind of metal is this? The little circuitry boards back behind it. What kind of plastic is this? Is it rubber? How do you make an LCD screen? I don't know. So knowing some of these maps inside of Pbr and how to isolate your different materials. These are all my materials that I pulled out of this texture. These are, I would call them raw materials. And so we have our plastic here. Red plastic. We have a white plastic. This looks like some kind of other plastic. But that's kind of my point. We got a few different plastics in here. We got like a brass. I would almost think of this like the metallic paint of the circuit board. And here's my LCD screen. And so when you're going to texture something, you need to know what it is that you're texturing. And so if we break it down even further beyond just the materials, well, how do we create these materials? And so these are all polished up, but if we take another step back, these are really like the raw elements. Okay, and so something like a brass, this is a rather rough brass, but then this is here might be like a more clean brass, like never been touched by human hands, or never been, you know, it's just almost like the raw ore itself. And so breaking down how to create these sort of raw ore elements like this has a lot to do with this process over here that I was explaining inside of the texture. We have our Albedo map, the Metalness map, and the Roughness map. And if we take a look here, I'll give you an example of, let's just take a look at this top row right here. And so this looks like just a metal row. The starting sphere here is a raw metal. It's really undecided, but it's a raw metal, and all we're doing across this gradient here is changing the albedo color. So it's the same metal with a different color all the way down. What you should know about the Pbr world, because we are working towards physically accurate, is that there is no realistic material, there's no realistic metal under a certain albedo color. And so in all actuality, all of these metals here that I just hid are not realistic metals. They don't exist in our real world. Because in our real world, if you were to go take a photo of a metal and strip away all of the, and let's do that here, I'm going to say flat color. If I strip away all of the light value in the Metalness workflow for a game, or Pbr rendering, the Metalness workflow, these colors don't exist for metals. There's no such thing. There is a realistic range of color for metals, and once you go out of that realistic range, you're out of realism. You're no longer hitting realism. You're making fake materials, stuff that doesn't exist in our world, which can help to author certain kinds of sci-fi, new age materials if you want to go that direction. But if we're trying to achieve realism, this is something you stay out of. These don't exist. And so this is really the beginnings of understanding that when working in a Pbr world, you can't just willy-nilly choose colors. You actually kind of have to know, is it real or not? What is my material? How does it act in the real world? What color is it truly? And then to break it down from there. So this next line here is really just about the roughness. And so if we take this material here, this metal, and step up the roughness, so this is a roughness of 0 down at the end, and this is a roughness of 0.8 and 0.6, and it's increasingly getting more rough, 0.4, 0.2, 0. 1. I think I did that backwards. This would be 0 roughness, 0.2 roughness, 0.4 roughness, 0.6 roughness, 0.8, and then 1, so full roughness. You may also see this talked about in other terms. This is also called, it could be called a glossiness shader, in which case the math goes backwards, because if it's a roughness map, as we go up to a value of 1, we're making it more rough. But if it's a glossiness map, as we go up to a value of 1, it's becoming more glossy. And so it's the flip. But in our Metalness Roughness workflow, we're going to be using roughness, and so that's how that works. So just the same metal, this is the same metal all the way across, just getting more rough as we turn up that roughness to a white value. Metalness. So that Metalness map, let's take a look back over here. Metalness maps are either black or white. I took a little bit of artistic freedom in here and was trying to experiment with putting some subtle dust in my Metalness map. Typically, that's avoided. So, starting with a metal, really this is all the same albedo color, okay? So it's not changing color, it's not changing roughness, we're just adjusting the metalness value. And you can see at a metalness value of 1, this is what it's going to look like. We're telling the render engine to be completely metal, 100%, and so it looks like a mirror. It's completely reflective. That's kind of what we're describing with the metalness. It's what we're describing with the Metalness map. And so as we step that down to 0, we got less and less metalness until we end up with something that's opaque, more like a plastic. And so these middle spheres are really just for demonstration. As you can see how it changes, it almost, as we're crawling across this, it almost starts to look less and less transparent almost. Like in here it almost looks like you're looking into a world, and then it starts to become more and more flat or opaque the further we go down. And so these don't exist. We either have, and what we're deciding with the Metalness map, we either have a metal or a conductor, or we have a non-conductor or a dielectric, which would be like plastics and other things that are not reflective like metal is. And so getting down to just the non-conductors, the dielectrics, because that's kind of where we transitioned. We went from talking about metals up here, now we moved over to plastics, non-metals. And so this is the same metalness all the way across. It'd be a metalness of 0. In other words, it's not a metal, 0 metal. And then this is just the roughness for those changing. And so we go from almost what looks like a hard plastic down to maybe a soft plastic to a rubberish material to where we get to something that's just possibly even, I don't know what I'd compare this to. Possibly dirt. Rocks. Non-organic. And then taking that same non-metal and adjusting the albedo color. So this is a non-metal of a different color. Just as in metals, you have a realistic albedo color, so it works the same on both sides. there are non-realistic values to non-metals. And that range is from this white to this gray. I'll give you a more specific number here in a bit. But that's really the first idea you should understand, is that to achieve realism, this doesn't exist, and really these don't exist. So these cover roughness ignored. So just talking albedo and metalness values here, there are realistic ranges for your materials. And so this range is kind of all the materials that you can, this range of values for albedo and roughness will give you any material in today's world. It is enough flexibility that changing the or setting the right albedo color, having the right metalness, it's either on or off, it's kind of yes or no, 1 or 0, white or black. They all have realistic ranges for achieving what you see in today's world. And knowing how these values can work, you can author your own materials and kind of do your usual artistic eye and create something that looks aesthetic but also believable, or is physically based, as they say. Now if we take a look at Albedo Colors, talking about realistic values, you see that almost, and these are a copy, so all of my metals here, talking about realistic albedo values. You can see that all of these, oh, these aren't really, there we go. You can see that all these values are in the higher range of color. They're closer to white than anything else, and this is me kind of talking about that albedo value being in that range. And if I step through my keyframes, I've animated these flat materials. That's the metalness value, and then that's their current roughness value. So that would be how you build out these materials. And so next set of materials underneath, this is that metalness value for these over here. You can see that all of these non-metals mixed with this albedo value create your plastics, rubbers, dirt, dust, everything that's a non-metal. And I have a few varying roughness values in here, but really just for keeping this or these raw materials, I'm using all the same roughness value. Any one of these could be any kind of roughness value, because we may have a brand new shiny metal or a really dirty and used metal. We may have a brand new plastic or a dirty plastic, or maybe even just an unfinished plastic. Maybe a rubber kind of plastic. And so we could use different roughness values to achieve those looks. And so going back to our texture over here, you can see that these are actually a bit more believable, if you will. I was using my artistic eye and what I know about albedo maps, metalness maps, and roughness maps to choose materials or to create materials that look good and not just shiny. And the great thing about all these materials is that after you've built materials, you now have these materials for life. You have these values for life. And so from here on out, if you ever need an albedo value for, say, chrome, you can go find that. And I'm actually going to open up my material editor here. Just going to show you guys what I built. Yeah, okay, so these are all these material spheres. Forgive the node order. I'm discovering a bug inside of Max that once you build a shader in the node order, you have to keep it that way. So if I flip my node layouts here, it goes back to normal. Interesting. So these raw values, or so these raw materials in the center here, I've built out as kind of like a template. And so maybe these metals, like here at the top, we have, what's this one named? Pbr Metalness Bronze. And so if we go look at this shader, which is a Pbr shader, we have, we need to check, make sure that our gamma is on when we're choosing Albedo Colors. It's important. Oh, it says it's on. Probably just needs to update the preview. Yep, that was the problem. Update. And so our albedo value for that, that bronze, is in that higher range like we talked about. I would break it if we did something like that. But if you know your values, we know it's metal, so it's white, and then we choose a particular roughness, which is just a default for my viewport. I went with like a 27% gray. Then we know how to make any of these materials. And just to kind of further illustrate, let me look at these maps here. Again, we're using Pbr metal shaders. We've kind of moved on from these legacy old school materials, and these are some of the newer Pbr shaders that are in the industry right now. So we have this one's been around for a bit, the physical material. You can see that there are a lot of options here. So a physically based renderer can get very complicated, but to make it easier on us artists, they simplified it, and we just got to understand how to break down kind of these three maps to get very similar effects to what more complicated shaders are doing. And then you have like the Arnold Shader, which gets even crazier. You got so much more control. This is good for commercial type stuff, visual effects type stuff, when we're getting very, very, very particular about our rendering. But when we're just making quick art, quick stuff for games, stuff that we want to make sure it looks good in kind of any lit situation, the Pbr Metalness Workflow, simplified for like game engines and such, tend to look like this. And there may be other ones out there, and render engines can support both. You'll notice that Unreal has both options in here, but this is a Pbr Specular gloss material, and really the difference in the Specular gloss is that our Metalness shader changes our metal effect, changes the color of our metal by sampling what's inside of the albedo. And where a specular gloss workflow is different is you actually have a specular color map, and you put, so this is not only it's not only like your Metalness map, so you need a particular value, a particular realistic value, but it also picks up color and will reflect that color back just like you did with the albedo color inside of the Metalness gloss. So that was a kind of just a PBR Quickie video. I hope that helps kind of you guys understand how to generate some of these materials. I would encourage you to kind of start building your own library. Again, this is just a PBR material, Metalness Rough, and we're using color nodes for each. Thanks for watching.